This is the 8th video on trigonometry, where we're going to have a look at solving some trigonometric equations where you're going to need to change the range of the x values that you're given. You know when you're going to need to do that when you have some function within your trigonometric function. So here I've got a 3x within the cos. Here I have got an x plus 45 within the sine. Here I've got a 2x minus 10 inside the tan function. So with all of these examples, I'm going to need to make a substitution and change the range. So here's what I'm going to do. I am going to make a substitution. So I'm going to substitute y instead of the 3x. By doing that, that allows me to simplify this equation to be cos y is equal to 0.4. This is a much simpler equation to solve than this one. By doing that, I am solving an equation for y instead of x. So that is going to affect this. I need to be able to solve to find y, not to find x. So y is equal to 3x, so I will have 3 of these. So my new range will be between 0 and 540. Because 0 times 3 is 0, and 180 times 3 is 540. So this is my substitution, and I've changed the range. This is really important. If you don't do this, you won't get the correct answer. Right, I've now taken this harder equation and I've simplified it to this. And I can solve this nice and easily. So y is going to be cos inverse of 0.4. So get my calculator, and to one decimal place I get 66.4 degrees. I need to draw my graph, and I'm going to draw my graph between 0 and 540 degrees. So 90, 180, 270, 360, 450, I'm going to need a bit more room, and 540. Cos goes like this. There we go. Okay, so the solution that I already know was about here at 66.4. I can see, looking across, I will have another solution here and another solution here. Using the symmetry of the graph, this solution was 66.4 degrees from 0. So I'm going to need to go 66.4 degrees away from 360. And if I do that, I'm going to get 293.4 degrees. And similarly, if I go to get this solution, that will be 66.4 degrees above 360. Which is going to give me 426.4 degrees. So, my 3 solutions for y are 66.4 degrees, 293.6 degrees, and 426.4 degrees. So those are my 3 solutions for y. But I wanted to find 3 solutions for x, not for y. The question asked me to solve the equation for x. So, I know that y is actually equal to 3x. That was the substitution that I made. So all of these things are actually, all of these answers here are equal to 3x. So if I want to work out just x, I need to divide all of these answers by 3. So if we do that, we will get there we go. So these are my 3 solutions for x. If I wanted to check that, I can go back to the original question. Cos 3x is 0.4. So if I times this by 3, do the cos, I should get roughly about 0.4. I won't get 0.4 exactly because I've rounded this, but it should be about 0.4. And the same for both of these. Next, this one here. Same process. I'm going to make a substitution, and the substitution I'm going to make is that y is equal to x plus 45. I'm going to need to change the range. So my new range, I'm adding 45 to both of these. So my new range is going to be from 45 up to 425. Adding 45 to here and adding 45 to there. Make the substitution here. So sine y is 0.3. So y is sine inverse of 0.3. Tap that on my calculator. And I get 17.5 to 1 decimal place. Sketch my sine graph. And I need to go all the way, I need to go past 405. So I'm going to go up to 450. The solution I know is this one here at 17.5. There will be another solution here, and there will be one more solution over here. To get this solution, I'm going to do 180, take away 17.5, which is going to be 162.5. To get this solution here, I'm going to do 360 plus 17.5 to give me 377.5. So I have 3 solutions for y. Now, I know that y has to be between 45 and 405. So I'm not going to include this one, because that's not in the range, it's too small. I had to include it because I used this to help me to work out these two, but it's not going to be part of my final solution. Now I remember that y was actually x plus 45. So I need to subtract 45 from both of these. So that's going to give me 117.5, I think. And that's going to give me 330. So those are my 2 answers for x. Okay. Third and final example, this one, a little bit more complicated than the previous ones. As you can see, we've got a 2x and a minus 10. So we've got two things that are happening inside my tan function here. I'm going to use exactly the same method as before. I'm going to make a substitution. Y is equal to 2x minus 10. I'm going to change the range. So the range for y here, so if I times 0 by 2, I get 0, take away the 10, it's going to give me minus 10. 2 times 180 is 360, take away the 10, it's 380. Simplify my equation. Tan inverse okay, sketch my graph between these values. Mark on the principal solution here, the solution my calculator gave me. So I've got my minus 21.8 here. I will have another solution here and another solution over here. This solution, I need to take away 21.8 from 180. So that's going to give me 158.2, I think. And to get this solution here, again, I'm going to need to take away 21.8 from 360, and that's going to give me 338.2. So, three solutions. My minus 21.8, 158.2 and my 338.2. In terms of my range, I'm not going to include this solution because that's too small, it's outside of the range, it's below the minus 10. These are both okay though. So y is 158.2 or 338.2. Then think back to the substitution. Y was equal to 2x minus 10. So to work out the x, I am going to need to add 10 to both of these solutions, and then I'm going to need to divide by 2. If you think about a very simple equation, if I had that equation there, I would add the 1 and divide by the 2. Same idea here, I'm going to add the 10, divide by the 2. Add the 10, divide by the 2. So if I add the 10, divide by 2, that's going to give me, just make sure I get that correct. And there we go. There's my solutions. So, this is the most important thing. You've got to change the range.